So today we're going to be making two-way frequency tables. A two-way frequency table is used to represent data in categories, and we need two categories. Okay, that's why it's called a two-way table, because it compares two different things. Tables show data pertaining to two different categories. For example, playing sports and taking a foreign language. If you either play a sport or you don't, okay? You're either taking a foreign language or you're not. And then we are comparing those two. So the players that play a sport and are taking a foreign language are in this category. And the players that are not people that do not play sport but are taking a foreign language are in this category. Each row adds up to the total, and each column adds up to the total. And then this is our grand total of 50 students, okay? So this is just a traditional frequency table. It's not we're going to be learning different types of frequency tables where we're actually going to be comparing two things. But this is just a generic two-way frequency table. So Lee found that 78 students in his class owned a cell phone, and 57 of those owned a iPod. There are 13 students who do not have a cell phone but do have an iPod. 9 students don't have either device. Make a two-way table to describe the results. Okay, so first off, you have to identify what are the two things that we are comparing. We have cell phones and iPods, okay? So it doesn't matter if you put cell phones on top or an iPods on the side. It just matters that if I put cell phones up top, no cell phones has to also be on top. If I put iPods on the side, no iPod has to be on the side, okay? So I'm going to put cell phone. No cell phone. iPod, no iPod. And then we have our total and our total. This box over here would be our grand total, okay? Right, so now we're going to fill in the information that we know. So we know a total of 78 students own a cell phone. So cell phones total is 78. Okay, of those 78, 57 own an iPod. So cell phone and iPod would be this box right here, and that's going to be 57. There are 13 students who do not have a cell phone but do have an iPod. Okay, so no cell phone but do have an iPod. So that's going to be in this one. That's going to be 13. 9 students do not have either device. So no, 9. Okay? Then we're going to look through all the results or find the additional missing pieces. Okay, so 57 plus 13 will give us our total for that row. So what is 57 plus 13? 70. 13 plus 9 will give us a total of that row.
21.
22. Okay, and then we can find our no iPod with cell phones by subtracting 57 from 78. 21. And then we can add this row here. 21 plus 9 is 30. Okay, now this is what's really important. Your total of your column and the total row have to be the same number. So that to make sure that you do this correctly. So what's 70 plus 30?
100.
100. What's 78 plus 22?
100.
100. So we did it correctly. All right. A relevant frequency table, this is also compares two different categories of data. Instead of showing the number in each category, it shows the ratio. What is a ratio? Also known as a fraction, okay? Can be given as a decimal or a percent. So I'm gonna only give you the decimals, but if we were to put this as a percent, what would be the percent of 0.38? 38%, right? So sometimes they might ask for the percent, sometimes they might ask for the decimal. Just remember that a percent, you just move it 2 decimal places back. So 1 as a percent would be 100, okay? This can be done by row or by column, okay? If we're doing it by row, like this one's by row, our row will add up. If we're doing it by column, our columns will add up. But if we're doing it by row, the column does not add up, okay? Because we're not comparing it by column, okay? This is also known as conditional relevant frequency because it doesn't compare to the grand total. It's only by the row or column total, okay? So you have this one, it's missing the bottom part here, okay? You're going to be filling in on the next slide, everything that would be filling in up on the board. So do you guys see how the next slide has this, looks like this? This is where you're going to be filling in the information that I'm going to be on the previous slide, okay? Does anybody not understand that? All right. All right. So we're going to first be doing it by row, because that's what it says, right? Row is the first one? By row. So we're going to be comparing the rows. And if you don't know, rows are like this. Okay, so maybe draw those arrows so that it helps you. Okay? For the one that says row, right here. Alright, so the reason why I'm doing it up here so that I can look at this table while we're doing it. You guys have it right next to you. I don't. So we have 6 in this spot here, and the total of this row is 9. So our ratio is going to be 6 over 9. And then we're going to find that as a decimal, which would be 0.66 repeating. And if we round, we always round to the nearest hundredth, so it's going to be 0.67. Okay? My next ratio is going to be 3 over 9. Which, what is 3 over 9? As a decimal. 0.33. And our total will be 9 over 9, which is 1. And if you guys think about it, 0.67 plus 0.33 adds up to 1. Right, so what is going to be my next ratio here of have not been to Mexico and have been, my next ratio right here? 5 over 16. And what is 5 over 16 as a decimal?
0.3125.
We're rounding it to the nearest hundred, okay? Please do not write more than that because these are percents, it would be just 31%. All right, what is going to be my next ratio? Nobody knew. It's sort of 11 over 16. Which would be what as a decimal? 0.69. And then our last one will be 16 over 16, which is 1. And if we add those up, that would be our 1. All right, and then we still have to do the total row here. So what is my ratio going to be here? 11 over 25, which as a decimal will be what? 0.44. Okay. And what's my next ratio? Yes. 14 over 25. Which as a decimal would be what? 0.56. And we'll have 25 over 25, which is 1. Okay? Sometimes they might just put 1 in the last column there because they don't put it as a ratio because it's just 1. However, you can do it both ways. So that's by row. Now we're going to do the same thing, but by column. Okay? This should have been up there. This is that. So I'm going to change that. So down below that, there was one that's by column, and we're going to have to do it by column now. Okay? So columns are down. So if you want to draw like the lines, the arrows for columns being down. Okay, so now I'm going to be comparing 6 over 11, which would be what as a decimal? Rounds up to 0.55. Okay, and 5 over 11 will be 0.45, and our last one will be 11 over 11, which is also 1. Okay, what about my next column? What is my ratio for the next column, the first ratio of the next column? 3 over 14. And what is that as a decimal? So 0.21. Okay, what about, what's my next ratio? 11 over 14. And what is that decimal? 0.79. And then we have 1 as our total there. And to make sure that, 79, not 71, 79. But to make sure that we add 0.21 plus 0.79, and that should add up to 1. Okay? And then our last total column, what is my ratio going to be for the first one? 9 over 25. And that as a decimal will be 0.36. Then we have 16 over 25, which will be 0.64. And then we have our total of 1 again, which would be 25 over 25. Okay. So joint relevant frequency is found by dividing a frequency not in the total row / column by the grand total. Okay? Underneath this, you might want to make like a little example. So that's what I'm going to do here, but you can put it on the bottom. But make sure you write joint above it, joint relevant frequency. Alright, so what this means, this is like our name, total, name, total, and this is our grand total. Okay, this is taking any numbers that are not in the total row or column and comparing it to the grand total. Okay? Then our marginal relevant frequency, marginal, it's like the margins, it is found by dividing a row or column total by the grand total. Again, you might want to make a little key for this. This is our name, total, total, grand total. And this is where we are comparing the total rows and columns to the grand total, the margins of our paper, okay? Okay. So, we're going to identify the type of relevant frequency, okay? Okay, so if it's by the grand total, okay, it's going to either be joint or marginal, okay? If it doesn't, if it's not being compared to the grand total, it's automatically conditional, okay? So conditional is the only one that doesn't use the grand total. So we can go in and identify all the ones that don't have 25 at the bottom first, okay? So this one doesn't have 25 at our bottom, so it has to be conditional. Say 25, this one does not, so conditional. This one does not, so it has to be conditional. Does, okay, not 25, so this one has to be conditional. All right, so now let's look at the rest. Okay, so here I'm comparing 3 to 25. So 3 to 25, is this joint or marginal? Joint is on the inside. So this one's going to be my joint relative frequency. Okay. How about 14 over 25? Okay, so we have 14 over 25, which would be a marginal, okay, because it's in the margins. Okay, 9 over 25, marginal, it's in the margins. All right, I'm going to change this 11 to a 5 because there's two 11s. It's not a good number to use. So if it was 5 over 25, what would it be? Joint, right? Because it's 5 over 25. What about 16 over 25? Marginal.